Welcome to Station 3, where we are going to talk about ordering real numbers using inequalities. And here's what's new: interval notation. Notation is just a way that we communicate mathematically what our answers are when we want to divide the number line into certain regions. So in order to explain interval notation, let's review the idea of domain. Domain are all of the allowable inputs or x values that we can input into a function. So let's say for A, I wanted to make a t-chart, an input-output chart for x squared plus 2x plus 1, which you might recognize as a quadratic. For this, I could put in -3. I could put in -2. I could put in -1, 0, 1, 2. If I put in each of those numbers, I am going to get some type of output. So with the quadratic, the domain of this function is considered to be all real numbers. And for now, I'm just going to write this in words. All real numbers. You can use the symbol of an R with two vertical bars or a parallel sign if you would like to use a shortcut. Now, this might make more sense when we talk about example B, f of x equals the square root of x plus 2. If I think about a t-chart for this function, I can put in the number like 3, because if I take the square root of 5, it's irrational, but it certainly is a number that's in the real number system. I can put in the number 2. That would give me the square root of 4, which is 2. I can put in 1, which gives me the square root of 3. I can put in 0, which is going to give me the square root of 2. But when I start putting in negative numbers, we have to start being careful. This is going to give me the square root of 1, so life is good. When I put in -2, I get the square root of 0, which is 0. But when I put in -3, I get the square root of -1. When I put in -4, I get the square root of -2. Those are not numbers in the real number system. Therefore, -3 and -4, and if I would keep going in the pattern, all negative numbers past that point, as we get more negative, would not be allowed in my input-output chart. So I have a domain restriction. It is all the real numbers, but it's all the real numbers that are greater than or equal to -2. Okay, let's look at C. Okay, on part C, if I would make an input-output chart for part C, numbers like -3 are going to work, -2 are going to work, -1 is going to work. If I put in -2, for instance, I would get 1 over -6. And so I would get a rational number as my output. 0 is going to work. 1's going to work. If I put 2 in, I get 5 over -2. Life is good. If I put in 3, I get 6 over -1. Life is good. But when I put in the number 4, I have an issue. I get 7 over 0. You are not allowed to divide by 0. It is okay to have a 0 in the numerator. It is not okay to have a 0 in the denominator. Therefore, 4 is not in the domain of this function. If I would continue with numbers like 5, 6, 7, all of those are going to be okay. But whenever you see a function where we are dividing, you have to worry about places where it causes you to divide by 0. So my domain is all the real numbers except for the number 4. So how do we translate this into mathematical symbols? Okay, let's take each of those verbal statements and let's talk about an inequality first. If I wanted to talk about all real numbers as an inequality, we want all the numbers that are between infinity and -infinity. I purposely do not use equal bars because you can't physically hold an infinite amount of anything. You can always add one more to it. So they don't get an equal bar. And if I were going to talk about a number line, I would shade the entire number line. Next, for all real numbers greater than or equal to -2, my inequality would be x is greater than -2. And if I were to draw a number line at -2, it would get a closed dot because anything that has an equal bar would get a closed dot. Okay. And I would shade everything to the right. Okay. For all real numbers except 4, I would use x is not equal to 4 as my inequality. And if I were to graph it at 4, I would get an open dot and I would shade everything else. So when you have not equal to, or I have inequality signs that are not equal to, those get open dots. Now we're going to translate this into interval notation. So instead of using greater than and less than and not equal to signs, and instead of necessarily using open dots and closed dots, we're going to use a system of parentheses and brackets. So whenever I have something that is closed, I'm going to use a bracket. And whenever I have something that is open, I'm going to use parentheses. So I would talk about all real numbers in interval notation as negative infinity to infinity. This is not a coordinate point. It is interval notation. How do you know the difference? You have to look at the context of the problem. All right, so when you use interval notation, the first notch should be where you're starting your interval. The second notch is going to be where you're ending your interval. So if I look at B and we want to translate x is greater than or equal to -2 into interval notation, notice how this place right here is where we start. And that place is a closed area, so it's going to get a bracket. We start at -2, but then we end at infinity. Infinities are never, ever, ever going to get a bracket because we can never actually physically hold an infinite amount of anything. They will always get a parentheses because it is considered not open, or it's considered open, not closed. Okay, this guy, x is not equal to 4. This one is kind of a pain. Here's why. I start my interval here, I end here, and then I restart and I end. You actually have to describe this number line or the inequality x is not equal to 4 in terms of two intervals. My first interval begins at negative infinity with a parentheses, and then it ends at 4, also with the parentheses because it's an open dot. Then I'm going to use the symbol union, meaning it also includes from 4 to positive infinity. That's how in interval notation you talk about all of the inputs that are not equal to 4. All right, there are some formal notes. These are also on page 3 and 4 of your text as a reference, but just to kind of give you some clarity, if I had an inequality where A is less than or equal to X is less than or equal to B, notice how it's got the closed dots and I've shaded everywhere in between. Because of the equal bars, I would translate this into interval notation as bracket A, comma B bracket. That's considered a closed interval. It's closed because you have actual numbers all in between here, including the endpoints. So it's kind of a closed region. An open region is like what I have down here in red, okay, where I don't have equal bars. So really, there's an infinite amount of points getting up into this open dot, just not including that dot, and that's why it's considered an open interval. So notice how, since I have open dots and no equal bars, that translates into a parenthesis A, comma B parentheses. Okay. If you have one of each, those are considered neither open or closed intervals. So notice here how this is closed, this is open, so that translates into brackets, parentheses. Okay, so again, open, parentheses, closed dot, brackets. Okay, so here's some examples. How would we translate -2 is less than x is less than 3 into interval notation? Well, notice how this is a closed interval because I have the equal bars. Therefore, you would have brackets, -2, 3. It is considered a bounded interval and it is closed. I have -1 is less than x is less than 4. There are no equal bars here. There it's going to imply parentheses. So I would translate that into parentheses, -1, comma 4. It's considered bounded and open. Again, this is not a coordinate point. It is an interval notation. So what we're saying is on the interval of a number line between -1 and 4, These are all of the values that would satisfy whatever problem you were discussing. It is considered a bounded, because I have -1 and 4, I do have boundaries, but an open interval. If I have x is less than 2, if I would look at this from a picture perspective, I would have an open dot on 2, and I would shade everything to the left. So this is considered an unbounded regions because I have an infinity or a negative infinity where the interval begins. So it begins at negative infinity, ends at 2, and it's considered unbounded and open. And our last example for this station is if I were to graph x is greater than or equal to 2, it would get a closed dot and shade everything to the right. So I would start my interval at 2, and since it can be 2, it would get a bracket, and then it would end at infinity, and therefore it's considered unbounded and neither open nor closed. If you have any questions, raise your hand and I will come and clarify. Have a great day.